Just a few days ago at CES, a huge story broke. Startup Donut Lab claims solid-state battery mass production. News broke. The market erupted. Giants like Toyota, VW, and Kettle, after investing billions and over a decade, it still isn't done. So how did the startup manage to take the lead? If making solid-state batteries was really that simple, why are battery fire risks still a concern nowadays? Let's begin. Let's explore. To understand solid-state batteries, we need to look at the liquid batteries in our cars. As the name implies, liquid batteries use liquid inside. Solid electrodes are placed at each end of the electrolyte. A membrane separates them to prevent short circuits. Conductive ions travel across the liquid, enables charging and discharging, faster speed, quicker charging, and faster discharge. But there is a catch. Battery electrolyte is essentially an organic solvent, which means they're flammable and can even explode. If the battery takes a hit and its barrier gets pierced, internal shorting causes heat buildup, turning those solvents into fire fuel. That is why even modern electric cars, no matter how well they're protected on the outside, risk of thermal runaway remains. Solid-state batteries eliminate the liquid, switched fully to solid ceramic. As a result, the battery has no flammable content. It's tough to make it catch fire. Safety is at its highest. More importantly, it requires less space, enables leak-proof construction with equal volume. Solid-state batteries pack more energy. Energy density higher than liquid batteries. Same battery weight, twice the range. That's why everyone in the industry talks about solid-state batteries. This is battery tech at its peak, and since it is the peak, achieving this demands overcoming countless challenges. In liquid batteries, the fluid gets everywhere, easily wrapping around the electrodes. Conductivity is superb, but for solid-state batteries, both the electrodes and the electrolyte are solid. To conduct electricity, you must bond two rocks fully. No gaps allowed. Gaps block ion flow. Charge and discharge remain unstable. Even with a perfect bond, after a few charges, heat expansion occurs. IT cracks inside. Just like that, the battery's ruined. Some solid-state battery material need extreme condition. If there is even a hint of moisture in the air, spoils immediately can emit toxic hydrogen sulfide. Standards are passed hospital sterile rooms at defect rate. Electricity and equipment costs. This battery costs a fortune. That is obvious. Now they're in the spotlight. How did Donut Lab achieve mass production? They switched tracks. Since you mentioned solid-state crystals as prone to cracking as stone, so they developed a special amorphous material. Its structure is like a sponge at the nanoscale. It acts like a sponge. When ions flow through it, this sponge freely breathes and compresses, unlike a rigid rock that cracks under pressure. This special design also fixes contact problems. Surprisingly, it extends battery life to their claimed level, 100,000 cycles. So they claim mass production is solved. Basically, it's all thanks to their materials breakthrough, a fresh way to tackle tough problems with finesse. The tech logic sounds great. Let's be realistic. Donut Lab focuses on electric motorcycles with small battery packs. The concept holds, but with much larger car battery packs is a whole different challenge, making them cheap and at scale for engineers, as well as scientists and manufacturers. It is a challenge on another level. The real showdown isn't about who builds a prototype first, but who can drive costs down to rock bottom. In this regard, I believe the real hope lies here. It's up to us. China leads in new energy, plus high demand. Globally unique manufacturers are involved, launching transitional semi-solid batteries as a production solution. In implementation, we lead. Donut Lab launched at CES, securing the first release, but making it affordable for all. That's true capability.